All right, we're going to use some equations to solve percent problems in this section, and it comes down to this equation here. So I'm going to put it in red for dramatic emphasis. The percent times the whole equals the part. And there's words that they'll have in a lot of the story problems that help us figure this thing out. The word of means multiplication. So often then when you're talking about what number goes in for this whole, the question will say something like, what's the percent of 64? So looking down here at example 1, this of 64 tells us that the 64 is going to be that whole amount. Then if you think back to what's the word that we use for an equals, that is often the word is, and so they'll say equals whatever that part is. And you get that same sort of thing here in example 1 down below, is 18. So 18 is the part. We'll come back to example 1, but I want to finish off this equation thing here at the top. So the last thing I want to say has to do with this percent right there. So that percent in the equation is always written as a decimal. And we did a little bit of this earlier this year. So my example is 38%, that whenever you want to take and change a percent to a decimal, it's always going to be 2 jumps of the decimal point. So right now it's 38.0 or 38 percent. So we need to go 2 jumps with a decimal point. So this thing here then is going to be 0.38. So in this first part of our equation here for the percent, we'd have to put a 0.38 if it was like a 38% sort of thing. The other thing is going to be if you get a discount, if you're trying to figure out a percent off, there's a couple ways you could do this problem. What I like doing is doing 100% minus the percent discount. So 100% minus the percent discount equals the percent you pay. So I'm talking about a question where they say, this is the cost of a new snowboard, but it's 30% off. Well, you could say 100 minus the 30% off, you need to pay 70% of the cost. So that then is going to be the number that you put in the equation. That percent you pay, that is what you put in the equation. So what you put in the equation. All right, let's do some examples of this stuff. All right, example 1. I kind of already spoiled the surprise a little bit, but let's start by writing that equation. So percent times the whole equals the part. I'm looking for you to write this down as you do these questions, at least for this first section. Then as you go through, we can take and fill in some of those things. So all right, my whole then is going to be 64 because it's of the whole. And is a word for equals, so you see that is 18, that goes in for the part. I should comment, sometimes it'll say 18 is what percent of. So it's not always is and then the blank. Sometimes you'll have the number before the is. But all right, then we have our percent here. That's what we're trying to find. We need to get the x by itself. So we look at what was done to x. X was multiplied by 64. We need to undo multiplying by 64. So the inverse of that would be division. And that'll cancel out my 64 over here. X equals, punch into a calculator, you get 0.28125. And it's not 0.28%. I didn't say it at the beginning, but we said whenever you put a percent in the problem, that percent is going to be written as a decimal. So we need to kind of do this part here backwards. That it's a point something in the problem. We need to take and move that decimal point now 2 places, but in the other direction. So here I have 0.38. 2 jumps will get me back to my 38% where I started. And that's what we do here in example 1. So I have my 0.28125. I take and move my decimal point 2 places. And that tells me it's 28.125%. And you could round that to 28% if you wanted to, but you always end up moving that decimal point. When you put a number in the problem, put a percent in the problem, or when you get a percent out of the problem, you have to move that decimal point back again. All right, number 2, example 2. I actually bought these Band-Aids for my wife. I think they're awesome. She probably doesn't think it was the best gift ever, but Uncle Edgar bought bacon Band-Aids off Amazon. They're usually $7.99, but he got them for 30% off. What did he pay? Well, that last line we had up above When given a percent discount, you do 100% minus that number. So if they're taking 30% off, and you really could do that in your head, but if you're getting them for 30% off, you only have to pay 70%. So we need to put 70% in the problem. But when we put a percent in the problem, we always move that decimal point 2 places. So 70%, we take and move that decimal point a couple of jumps. So we're going to take and put a 0.7 or a 0.70 in our original equation. All right, so we write down that original equation. Percent times the whole equals the part. And now we don't have those nice words in here, the of and the is, but we could at least say, all right, I'm going to put my 70% in here, so 0.70 for my percent. And I don't see a of or is, but the whole, that's going to be the amount before that discount. And the part is going to be the amount after the discount. So they're usually $7.99. That's the whole part, the whole cost, $7.99. And we're trying to figure out X. We're trying to figure out, well, what do you actually end up paying? So you could take and punch that into a calculator, 0.7 times 7.99, and you'll get 5.59. And you could write equals X if you wanted to, but that's going to be the part, that's the cost after the 30% off. Or you could look at it as though that's the 70% you have to pay. All right, so one last type of question we could have here. I'm going to start by writing the equation. So percent times whole equals the part. And we have our 14%, but before we put that in, we have to move the decimal point a couple places. So I have my 0.14. Then we see that word of, so we know that the 3,000 is going to be the whole amount. And the part's what we're looking for, so you could put an X there if you wanted to, or you could just punch it into your calculator. 0.14 times 3,000 gives us 420. So 420 is going to be 14% of 3,000. All right, you could jump down to example 4. 36 is 80% of what number? I'm going to start by writing that equation again like normal. So percent times the whole equals the part. And we have those words in there, so 36 is. So is like my equal, so 36 has to go over here for the part. And we have that 80%. Well, before we put an 80% in, we have to move that decimal point 2 jumps. So it shows up as 0.8 or 0.80, you could say. And then of what number? So of what number? The of is like that multiplication there. So the what number is the whole. And we want to get x by itself. Well, what was done to x? They had multiplied by 0.8. So we need to do the inverse of that. We divide by 0.8 or by 0.80 and take and punch that into a calculator, and that should give us 45. So 36 then is 80% of 45. So our equation has 3 different places where the unknown could be. It could be the percent we're looking for, it could be the whole, it could be the part. If you go back and look at these 4 examples, we hit at least each one of those once. And I think you'll find that's true as you go through to the homework. So in theory, that's what we learned, and that's what the homework is. Let me know in class if you have questions. Be glad to help.